All right. Thank you very much. Good morning, everybody. Not only did I manage to pull the hangover shift, I also have to follow the 800-63 announcement and the kids panel, so absolutely have been completely upstaged no matter what I say or do right now. But anyway, good morning. I'm glad you all were able to make it and survive the block party. My name is Justin Richer, and I'm an independent consultant working out of the Boston area. And I'm here to talk about what I have always found a fascinating topic, and that is the whole idea of a runtime gray list. Now, before we get into what that means and how that's structured, I want to ask you a simple question. If you walk up to this door and I tell you that you jiggle the handle and pull the gate and stuff like that, the door does not open, is this a locked door? You can see that it's got a combination lock, it's got a key lock and all this other stuff like that. Would you call this a locked door? Hands up, people say. Yeah, a few people. All right, I would not blame you for saying that's a locked door. What about now? Is this really a locked door? Because there's something I want to point out about this. Not only is the gate code fairly simple and easy to memorize, and not only is it posted near the door, it is posted on a piece of metal that has been riveted permanently to the gate. This, I would contend, is not a locked door. This is a very inconvenient unlocked door. Because just like an unlocked door, anybody that walks up to it has everything they need to be able to open it. The problem with this is that this is an unlocked door that we like to pretend is locked. And therein lies the trouble. And that's really at the root of what I'm talking about here today. We have a lot of systems that we like to pretend are locked and secure that really aren't, right? Because this metaphor goes even a little bit deeper, because is that door really locked? Turns out it actually is, but it has nothing to do with the lock on the door. Because somebody realized that the door was unlocked, but they didn't want that, and then wrapped a chain around it to make it locked again. And yet all of that is still functional. That combination lock is actually still active along top of the chain. And the reason that things like this happen, I mean, stuff like this happens all over the place, is because this door and all of these locks, they focus on the security at the cost of the functionality. Think of the path that we got to have a door like that, okay? First we have an open area. Anybody can get in and out. All right, fine, but now we put up a fence. Now, fences are great at, keeping some things on one side and some things on the other, whatever. But we realized that we didn't want everything to remain on one side or another, so we had to put a door in that fence. Lovely, but we only wanted some people to be able to go through the door, so we put a lock on that door. But then we realized that was too hard for the people that were getting through the door, so we posted the combination to the door, and then we realized that anybody that could walk up to the door could use it again, so we put the chain on the door, and now only the people that have the keys can do that, and we're just kind of going back around. Probably there is some poor security guard at the front gate of the complex where I took those pictures that has the key and will open that door for anybody who walks up and asks nicely, because that tends to be how these systems work. Every patch requires additional workarounds. Each additional workaround requires more patches. And I'm here to ask, can we do better than things like this? Right? This is a metaphor for how we build our security systems in the real world in a lot of ways. Well, the reason that we end up building things like this is we have a what I consider kind of an odd and incomplete model of security. We've got the bunch of stuff that we care about. It's all kind of sitting in one place, and we have the people that we want to be able to access it, the good guys, if you will. And we want the good guys to be able to get to the stuff, but we've got a bunch of bad guys that we don't want to be able to get the stuff. So in order to do that, we put this big thing called security in the middle, right? So we've got a guard, and we've got a guard dog, and in order for security to do its job, we give the guard a list of good guys that are able to go and get the stuff that we're protecting. This is a model known as a whitelist. This is a very traditional security model in that we say anything that is on the whitelist is allowed to happen. And anything that's not on the whitelist is automatically not allowed, because we don't know you, we can't let you through. We don't know what you're trying to do, we are going to say no. So where's your use case in this? Now, the people that are designing the whitelist say that, well, most of the use cases that we care about, they're over here, because these are the ones that we put on the list. If we didn't know about them, we wouldn't have put them on the list, and so they're there. And they will also tell you that, well, because we did a really good job making this list, all the use cases that end up kind of way over here, well, this is stuff we don't want to have happen anyway. This is like, one of our competitors coming in and stealing our trade secrets off the core database or something like that. We don't want that to happen. And so that is very rightly on the blacklist in that everything else box. But what if your use case is not quite all the way over there? What if you've got something where, well, maybe if somebody had been around when the whitelist was forming, they could have said, yeah, this is a thing that I need to do. There was a case that got brought up a couple of times earlier this week about a social media manager being blocked from using Twitter and Facebook at work. And I love stories like that because that's something that very obviously should be on the whitelist. That is allowed, but it wasn't allowed as per the policy with the way things were set up. So the whole value of a whitelist-only based security model is based on how good your predictions are. How good are you at figuring out who's doing things, what they're doing, what they want to do, and how accurately can you codify everything in your description language? Now, this track is being hosted by Axiomatics, and they will be happy to sell you something that gives you lots of power in expressing all of these wonderful rules and things like that. But you still got to be able to translate it to that thing, right? You still got to know about the use cases and put the details in and be able to make those predictions. Because what if your use case is right on the border? What if it is something that if anybody thought of it for half a second, it would be obvious that this would be on a whitelist, but nobody did? And we are coming up to more and more use cases that look like this in today's world because our data and the stuff we care about is no longer in one place. It's scattered all over the place. We've got, cloud systems and remote services and all this other stuff, people working remotely. We got your good guys are going to be everywhere, sometimes where the data is, and sometimes they're even going to be on the move. But even though the good guys are everywhere, that also means the bad guys are also going to be everywhere, right? And we need to be able to differentiate between the good guys and the bad guys. And, sometimes you can tell because the bad guys obviously wear a hat, but sometimes your good guys also carry around a hat because maybe they're bad guys at some point. You need to be able to tell those kinds of things apart. Where do you put that security booth in this world? Now, we try to sprinkle them throughout, and that poor dog is just kind of mad at a good guy over there, and he doesn't know why, because where do you put a whitelist in a space like this? Now, you might be thinking like, oh, well, for each of those little booths, I can have a little whitelist, and I can have my own rules and stuff. Okay, great. What if my use case is I need to connect data from there to there? And that is a legitimate thing that I need to do. How do you codify something like that in this world, right? The world is not black and white. The world is not immediately and directly predictable like this. So instead of having a whitelist only, and then everything else is disallowed, we need to have a gray list. Now, a gray list is all about, you still make a whitelist. Anything that you know about, you definitely know that, yes, this person can do this thing to this data and move it over here. But you also make an explicit blacklist of, all right, these are the cases, you think about the cases that we really don't want people doing these things. Everything else goes in the middle, goes in the gray list. And that gray list box means ask someone. Ask someone. You need to make a runtime decision of whether or not this kind of thing is allowed. And the most common person and the most obvious person to ask is the end user. There we go. Because managers often have a model of what users are trying to do, and security architects try to make a good guess about what users try to do. That's how we build our whitelists. But the users, the people that are running the system that are trying to do their jobs, they know what they're actually trying to do. Now, I was careful in phrasing this slide because they might not know what they're really doing, but they know what they're trying to get done. And that's important because users are ultimately the ones that are really in control. Because just like that gate, saying no constantly means people are going to find workarounds. So if anybody here saw my talk on shadow IT earlier this week, we went through a bunch of different ways that those workarounds can crop up. And workarounds usually end up being worse than if you had just left the door unlocked to begin with, right? So stop abusing your users and give them the power that, quite honestly, they already have. Now, you've all seen gray lists in action. They're all over the place here. Anytime you see something pop up like this, it says, hey, it looks like you're trying to do a thing. Is this the thing that you're trying to do? This gathering of consent and authorization is a gray list in action because the system said, I don't already have an answer of whether or not this is something that I should do. I don't know if it's okay for you to log into that system and give all of your information over. So I'm going to ask if you are really trying to do that. Gray lists are by definition contextual with what people are trying to accomplish. And the decisions of those gray lists are also contextual because who gets to make those decisions? Oftentimes it's the user, sometimes it's not, as we'll see in a minute. When do you ask them? Do you ask them like immediately as they're going through? Do you ask them later on? When they say yes, does that mean yes and forever and always? It will always be a yes. Or when you say no, does it mean that never ask again? And, well, all of this context adds some really interesting flavor because I told you before that there were 3 categories, and that was a very subtle lie. Because really, there's a spectrum between the whitelist and the blacklist. One could even say that there are about 50 shades of Graylists. All right, get the picture. All right, good. All right. So, and this is really, we've seen already there's some context to making these decisions. So what if your use case is, all right, so the site is registered, other people have used it before, nobody's reported this thing, and I just don't know if this user is really trying to go and do this thing, so I'm gonna ask the user. I'm gonna say, what are you trying to do? OAuth and OpenID Connect really made this pattern famous, really made this thing work. This is how a lot of sites today connected internet scale, by asking the user at runtime, is this what you're trying to do? But asking that consent properly is a really hard problem, as it turns out. Because just popping up something that says, are you trying to pass a bundle of attributes including a subject identifier with the following random value to this client identifier with the following also random value? That doesn't make sense to users. They're just going to kind of glaze over. Asking consent properly is hard. So how do we empower people to make good decisions? One of the best models that I like to think of is, I'm gonna go back to doors, and you provide context. Now, if I walk up to this door, and I love this door as an example, if I walked up to this door, I know it's gonna happen. I am being warned that if I crash through this door, an alarm is going to sound if this door is open. That means that I, in that context, can make a decision. Am I currently on fire or about to be on fire? If the answer is yes, then yes, I'm going through that door. And if the answer is no, maybe I'll try to find a different door instead. And another thing that I really like about this door, and this is really subtle, is up here you can see a little brake tab. You don't see these on many doors, but this is one that shows after the fact that this door went through. In other words, that's an audit mechanism. So not only did somebody crash through a door somewhere, we know that people went through this door, and it should probably be rechecked and reset and all of that other stuff. So we know where something happened. You also need to be clear about what you're asking people, because this is a case that's trying to say the same thing that the last door did. This is an exit, but only in emergencies. So it has the emergency exit sign up here, but it says it's not an exit. So is this a door that doesn't work? I don't really know what's going on here. And you need to be clear about the consequences, because in this case, maybe I go up to the door and I'm about to be on fire, but I really like my membership of this club, but I don't want to give that up. So I'm going to go try and find another emergency door that won't revoke my membership. But that's probably not what this message really means, right? So we need to be very clear in helping people know what's going to happen when they go through that door and what actions they are allowed to take. Because if I go up to this emergency door and I'm not an employee, and I'm about to be on fire, I have no idea what's going to happen. I have absolutely no idea. So asking consent is hard. There's a lot of good research, HCI research in the area, and it's ongoing. But what if you've already asked the user previously? So this is a case where it's, not an emergency. I've asked somebody, like, are you going to try and, move this data from over here? I've already asked you. You've already said yes. Should I ask you again? Well, the paranoid security nerds among you say, well, yes, obviously every time you need to reaffirm that this is really what's happening. But usability research says that that's really annoying. Because when people keep seeing this, it goes what a friend of mine calls Pavlov's approval page. Because we display something like this, and we do all of our research that try to clearly state that this application is going to go and do things, and you can allow it or you can deny it, and we try to give all of this wonderful information, and that's good. But if we overload users with this is what they end up seeing, right? Only one button on this dialog means anything, and that's the click here to make it go. And if you don't believe me, when's the last time you read an end user license agreement fully before you clicked I accept? Anybody? Once in a while. You're weird, but thank you. Something called trust on first use, or TOFU, is a model that works really well here. You give everybody the context when it's something new, when it's something unknown, or even when you have kind of a question about it. Because these gray lists can be intelligent. It doesn't just have to be like, oh, I have not seen this exact thing and whatever. It could be, all right, I've seen this before, but I'm not sure that user's really logged in. Maybe they just changed their password, so I'm going to ask them again just to make sure and set up some alerts and things like that. There's a lot of things that you can do intelligently. But if I am pretty sure that it's the same thing that's happened, just let it through. This is an end of the gray list that can basically act like a whitelist after a decision has been made. Now, if that use case ends up being kind of further down the line, we might not ask the user, because the user is not the only person we can ask. We could ask a third party who has authority. So maybe the user is trying to get into some type of special inner sanctum. Maybe they're trying to get, special access to a server cluster or something like that. We might not want to ask them if it's okay for them to log in as root to the production server cluster. We might want to ask somebody else at runtime if it's okay for that user to go in and do that. We can do this with today's connected systems. And if you want to see more about that, come to my talk with Eve Mailer this afternoon on a protocol that helps allow that called UMA 2.0. That's today at 2:15. And just an aside, it's going to be an absolutely epic talk. So definitely come check that out. And when you say yes to one of these things, you want to be able to review it later, to know why you said yes, why you allowed this, why it made sense to do that, or why it made sense to not do that. If you disallowed something, you want to look at that. And the key to that is auditing. You need to be able to write down everything that happens, who made the decision, when did they make it, what were they trying to do, have they done this before, and only then when you write down all of those recordable questions can you ask the human question, why were they trying to do this? Now, gray lists are predicated, just like the whitelist, on decent boundaries, on defining a good whitelist and a good blacklist, because the fewer things that you have to ask a user about, probably the better you can do, because that means your world is better defined. Your world is probably better understood if you have more of it modeled out. But anything that is not modeled and fully understood still gets dropped into that gray list where somebody can make a runtime decision. Now, there's also an interesting use case for whitelist that I like to call an active whitelist, where you're still using a whitelist style transaction, like OAuth and OpenID Connect, where you are sending the user to an authorization server and making them log in, but you're not prompting them with an authorization screen. Now, this could be just for the TOFU use case, in which case you don't know that the user's allowed to do that until they get there, and you're like, oh, okay, yeah, they've done this before. But for truly whitelisted decisions, why would you ever do that? Well, it allows you to confirm users' presence. Instead of having an API key that says, no, trust me, I'm working on behalf of a user, you know that the user's there, even if it's going between two back-end systems. And you can record at least intent of action. Somebody trying to, or at least it looks like somebody is trying to connect two systems. None of this is foolproof, of course, but it is helpful to add this additional information in. Now, in the old days when we only had whitelist and then everything else, there was a lot of effort that goes into making sure that whitelist only has good stuff on it, and then once it was there, you don't touch it. Never pull something off there, never, barely ever add more things on there, because that is the sacred core of security. This is what you're allowed to do, and everything else is bad. Well, with a graylist-based model, moving between categories isn't that scary anymore. Because if I have 1,000 users or more that are all doing the exact same action between two sites, maybe I should whitelist that. Maybe that's something I want to look into. Maybe it's something that I want to understand, because this is obviously something people are doing. They are making this decision. So I can stop prompting people and stop annoying people for things that they already know that they want to do. And inversely, if you have something that you've modeled onto the whitelist and nobody's using it, maybe it really is an exceptional case. Maybe really there should be some type of runtime alert to somebody, to the user or to an admin, or extra auditing or something that happens. You need to understand how all of these things are working. And of course, users don't make perfect decisions, And sometimes you discover things when people are going around the edges of the gray list, and you discover, you know what? Maybe this is a thing that we don't want to allow anymore. You can move things from gray to the blacklist. So these boundaries are important, but in the end, the boundaries really aren't all that strict. And I hope that we can get to a world where we have everything in one box, and it's all different shades of gray that help us understand what people are trying to do in the real world. Thank you very much. And I think we've got a few minutes for questions.
All right, awesome. Thanks, Justin. Any questions for Justin? Here we go.
Awesome. I wasn't sure we'd get questions because it is rather early.
When you're talking about Graylists and you're talking about the decision process to make the decision whether something is still acceptable in the Graylist or not, are you looking at using some sort of numerical scale where it's kind of like an adaptive control where, you know, if you're below this threshold, let it through, but if you're above, then you're blocked?
That's a really great question. I don't know, let's all throw it into a TensorFlow network and see what happens. This is I'm joking only slightly because this is an active area of, and a rather nascent area of security research is how can we use adaptive, scoring and modeling technologies like that to figure out okay, there's a lot of stuff that's going on. Today, and in my personal experience, it's been a lot of manual review of audits and statistics. So you pull up that stats page of oh, we have 3,000 people logging into this website, it's stackoverflow.com or something like that. Maybe we should understand what stackoverflow.com does and why everybody's going there with their corporate identities. And so those are the kinds of things that in my experience it's been. That unfortunately only tends to get things at the edge, the kind of really exceptional conditions, because humans are really good at picking out those exceptional conditions. AI systems, I think, will give us an edge in being able to pull out more subtleties and more trends to say oh, you've got this cluster of similar things that people are doing stuff with, and maybe this is something to look deeper into. So I'm really interested to see where stuff goes. The theme of this year's conference is intelligent identity. I don't think we're there yet. I still think identity is pretty dumb today, but we're getting there. We're moving in that direction, and this, I think, is really going to be key for it. Because if you had only an intelligent whitelist, then that's not very helpful, because occasionally, due to some algorithm I don't understand, the computer says yes. Otherwise, I have to find a workaround. Thank you. Here and then.
Yeah,
go ahead, Sal.
No, thanks, Justin. So might it be pattern recognition, right? So I mean, I'm thinking back to my old machine vision days when, we digitized everything in grayscale, and then basically I would connect the dots, right? At the end of the day, say, yeah, that's a widget.
So you actually want to use literal color values?
No, and I wasn't literally thinking that, but I would think that there are that somehow you could you could either do a sort of normative correlation to things, or you could neural net it.
Oh, yeah.
And that those might be ways, and that the grayscale might just be ways of characterizing a pattern as opposed to a range, right?
Yeah, absolutely. I mean, I show it as a single dimension here, really for simplicity, but there's a lot of variables that go into this. Who's asking? How sure are we that we know who they are? Where are they coming from? What are they trying to do? Has anybody else asked this before? Have they asked this before? There's a lot of stuff that can go into this calculation.
I mean, it could also be the input into the thing, right? So you could use the grayness as input to behavior that later you're going to authorize or access, right? So
absolutely.
So you could let this thing run, see what you get. Then when you know what you're capturing, then it becomes an auth-Z engine of some sort. Right?
Yeah, absolutely. And that's what a lot of adaptive auth, we had a question in the back first. And I think we have only time for these two. I think we're about to end. That's what a lot of adaptive auth systems are already doing. And so I think we need to see the combination of that plus empowering users to make the hard human decisions in the middle and then learn from that as well.
Justin, he kind of touched on one point. I was going to say, don't you see this as a good supplement to behavioral analytics?
Yeah.
And also, how many times is the user going to be prompted, are you sure you want to do this? And does it remember each time?
Yeah, and so that's why I think eventually that's going to need to be adaptive too. Today we're following a very SSH style model of if you've ever SSH'd into a system, you get that key that you can't understand or remember. But the important thing is the system says, I haven't seen this key before, and you can make the decision, I'm logging into a new computer. So sure, you haven't seen it before. That's the only decision the user needs to make in that context. After that point, as long as that doesn't change, tofu is working. I think we can get better than that, and I think we will. So, and we have one last thing, if we have time.
One more question? Sure.
Yeah. So super quick, yes or no question. No.
Oh yeah, no, it will be a little bit more than that. You were talking about the advancement into the modeling, but do you have any insight to share on how to model this? What tool are you using? Because it can be very complex to reflect the business needs and all the use cases and things like that. So small insight on how you do it as an expert.
Yeah, so right now, I think a lot of what's going on is manual translation into sort of simple, executable, deterministic rules the system can understand. So thinking in terms of OAuth, is this client ID allowed to ask for the following set of scopes for the following set of users? Things like that are very codifiable and very easily mappable to, these scopes mean a set of actions, but it's a human that's making that correlation. And if the answer is, I don't know yet, then I can prompt the user as part of that process and on the way through. I don't have a deep background in modeling and simulation, so I'm not really the best person to answer like how we codify these, but I do know that we are starting to codify these things in more dynamic ways, as the folks who obviously know a lot more about this than I do brought up, and I think that is the future of where things are going. The core argument that I'm making here, though, is that it's okay to not have an answer, not have a yes or no answer, or be something that you're not sure about, because we have these other auxiliary processors that we call users and admins and other folks like that that can help us make these decisions at runtime that we didn't anticipate.
Awesome. Thanks so much, Justin.
Thank you all
And,
very much.
Yep. Speaking of scopes,